I hope everybody is able to see my screen.
Yes.
Yes, Ganesh.
Just take this the aptitude question. Given a two columns A comma B, so the result was provided here. I want you to guess this number. So just I will give you 1 or 2 minutes. Please go through it. So you are given two inputs, and this is the result. So can you guess what could be this number?
Mm,
It's 24.
24. Okay. Anybody else? Everybody is 24. Any other answers? Okay. Yeah. So I just wanted to know if whoever told 24, can you tell me why it is 24?
I just calculated it the way like 7 times 2 is 14, so 8 times 3 should be 24. That's why I calculated it.
Okay, then is it following this one? 7 multiplied, 6 multiplied with 7, 5 multiplied with 6. All right.
Mm.
So everybody, maybe you guys are looking for the pattern, right? Trying to do the
Yeah.
pattern matching from the historical data. Is it what everybody is trying to do? So can we make this logic, whatever your brain is thinking, trying to find the pattern from the existing data and guessing the new output? That's what everybody is trying to do. So probably you guys are trying to do A multiplied with the B, maybe A and B, A plus B or A minus B, A plus 3B, whatever the X n number of patterns will be there.
Yeah, it's doable.
But if you seen that previous 7 to 14, but 6, 7 should not be the same pattern, right?
I'm sorry?
No, no, 7 to 14 is fine, but if you see the
Mm.
previous record,
No, this
6,
was pattern
7,
was
but
broken. The
yeah,
pattern was broken, right? So yeah.
yes.
So isn't it like two different patterns are there? Like if it is the column B is greater than column A, then
Mm.
it is considered as column B. And if it is lesser than that column A,
Mm.
then it should multiply.
Yeah, so, some kind of a pattern you are coming with. If the B is higher, the number A and the B is better, some kind of a complex pattern you're trying to come up with. That's good. Yeah, that's really good thinking. So, so the way whatever however you are thinking, the exactly AI also will think in the similar manner. It is trying to understand the pattern from the previous one. 1 minute. It is trying to understand from the previous patterns and find whatever is there. So in the technical terms, we call this as a training data. Wherever we have the inputs and outputs were present, we are feeding this data to the model, observe the pattern, and guess what could be this one. This is our testing data. You got it? So, how it is different from conventional programming? Nearly conventional programming, nothing but how you will write. You will have an input, and you will write a logic, and computer will generate an output. That is what in general normal programming will take place. If you guys are wondering what is the answer here for this particular uh, thing, the answer is, do you want me to tell the pattern? What is it?
Yes, please.
Oh yeah, minus p plus 2. Now tell me the answer.
15.
Exactly. 15 is the answer. It will satisfied with most of the things, right? 2a minus p plus 2. For all these conditions, it will be satisfied. You can check. Got it? Any doubt here? Is satisfied, right? So I came up with this pattern. And how the AI will find this pattern? How the AI will find this pattern? So AI will have some algorithms. You train this algorithm with this training data and the model you will be generated. The algorithms are mathematical algorithms and you use the training data, feed it into the algorithm, nothing but you're training it, the output will be a model. This is what it refers to the AI model. Okay, these algorithms can be complex ones. If you go for the machine learning will have the set of algorithms. The algorithms were defined into regression and classification. The regression itself is linear regression, support vector machines, logistic. So many algorithms were there. And the data, so whatever we have, depending on the task, here I have just taken a simple task to observe the pattern. This can be a data from the realistic, like you have the housing data. Suppose in the house, you have the area of the house, number of floors, number of bedrooms, number of bathrooms, so etc. information was there. Your output variable will be the price of a house. So you're given all the information here, the A comma B, only two were given. But here n number of A comma B comma C comma D, everything was there. Each and everything is a feature of the column name. The area of here my goal is to predict the house price. So what can be the features of a house? Area of a house, number of floors, number of bedrooms, number of bathrooms, maybe it is having garden area, whether it is having a garage, yes or no. All those things can be features. You may be hearing this word feature a lot. And given all this variable data, maybe I have the data of 100 houses. Now I have the new house, 101 house. Can you observe the pattern of this 100 houses given the all the variables and features with the price? And I want you to predict what will be the price of a new house. Right? That can be possible. So far, I have been talking about the numbers. Here also I am talking about the number prediction. Right? Numbers are continuous variable. The number alternative name for the number is continuous variable, right? Instead of a continuous variable, What if you have a categorical variable, like whether the person is having a diabetes or not? Yes or no kind of a question. Whether the person is having a cancer or not? Yes or no? Whether the given customer falls under the high revenue making, low revenue making, or medium revenue making customer. High, low revenue, three classification. Given a photo or image of a animal, can you segregate or classify that one into the cat or dog or horse? These and all classification problems. So the entire AI, especially the machine learning, got split into the regression and classification models. And one more is there, which we call it the clustering. I will talk about the clustering later. Okay, what is the regression? Whenever the output is a number or continuous variable, we call that problem as a regression problem. Whenever the output is a categorical variable classification, like suppose you are given information about uh, the person users, like whether his income, his number of cars, whether he own a house or not, everything information was there, and you wanted to predict whether you wanted to give a loan to him or not. As a banking, you are working for a bank, so you wanted to predict whether this person is suitable to provide a loan or not. Yes or no kind of a question, right? That is a classification. Okay, either given an image, you segregate into the. Can you give some examples for regression and classification? Just where you can use it. I just want to hear one or two from you. Where you can predict regression where with the number, classification where with some category. Can you create some problems or whatever you have seen in day-to-day life?
Classification can be used for insurance industry.
Okay. So for what? Whether you wanted to, what is the problem statement in the insurance industry you wanted to solve with classification?
The person who is applying for the insurance is eligible or no
Very good.
for.
Yeah. Yeah. So classification, you wanted to whether the customer claimed something and whether that is the genuine claim or fraud claim. That can be one of the use case, right?
Yeah.
Yeah. And one person is saying sales, customer, e-commerce sales. Yeah, prediction of the sales probably. That comes under what? Regression. So you have the previous historical sales, and you wanted to predict what could be my sales in the next coming month or next coming quarter. Right, that is a good example. Yeah, sales and the insurance. Yeah, good. And
Yeah. If you go with banking side also, right? Credit check.
a credit check, whether you wanted to, whether the person is having good credit or not,
Eligible
or you
to,
wanted to,
yeah.
whether he is eligible for the credit
Yeah,
to
if
give a loan.
eligible to get the loan or something, right? Credit card or something.
Correct,
I
correct,
mean, certain
correct.
limit they will be put it, right?
Yeah. Suppose
If
if
it
you
is
are
in a greater
predicting,
sum,
correct. So suppose if you are predicting whether the person is eligible or not, that is a classification. Suppose if you are predicting how much he is eligible, that is a regression. Suppose he is eligible for the 10 lakhs of loan, eligible for 20 lakhs of loan. That is a number. That is a regression. Right? If the customer eligible or not, yes or no kind of a question, or maybe you are given a like the multiple choice questions will be there, right? You have to choose one of them.
yeah,
That is like
yeah.
classification.
Suppose, yeah,
Mm.
if the person having a good credit score and
Mm.
based on his profile, they are offering 10 or 20 lakhs loan, right? In
Correct.
that scenario, if you can, that amount we can give it as a regression, right? Or
Yeah, amount. If it is if your prediction is an amount number,
yeah.
we call it as a regression. If your prediction
Okay.
is about the category, we call it as a
No,
classification.
yeah.
Yeah, kind of
Okay.
a thing.
Yeah.
Okay, so classification will have binary classification will have yes or no. Multi-class classification will have the multiple categories will be there. You have to predict from the given set of categories. Given suppose you have 10 animals, the image was given to you. You have to segregate that animal, that particular image into one of the animal from the 10 categories. That is a classification. We call it the multi-class classification instead of binary class. Binary classification where you have to choose from only two. If you have more than two, we call it as a multi-class. Okay, suppose in the regression and classification, both comes under the supervised learning. What is the supervised learning? Okay, this both comes under supervised learning. The supervised learning, I have the input, A comma B is an input, and you're predicting a target, nothing but output is the result. Both were given to you, and we're training the model on top of it. Correct? Both inputs and output was given, and you're training. That is what we call it as supervised. Nothing but you're having a teacher who knows already answers, right? Then we call it as supervised, then only you can do the training. What if I don't even have this entire result field? Only you have an input. What can be done with the input? What can be done with this input? For example,
Pred-
yeah, tell me.
Predictions can be made like the way we were trying to make the patterns and try to get the answers.
You don't know the answer, right? Because this result is not there. What answer you will try to find the pattern for?
Right.
Correct?
Mm-hmm.
So yeah, so what problem can fall under this one? Suppose I will take the customers of the telecom industry. Okay, suppose let us say take Indian customer base, and or even for the e-commerce, you can take for anything e-commerce customers or like Amazon, your everybody is purchasing from there, right? So my goal is to segregate the customers into three clusters. Cluster one, I don't know. I wanted to have the similar mindset people into this cluster one. The other similar mindset into the cluster two. Or groups. Cluster is nothing but some group of people. Okay? Cluster three. Group one, group two, group three I made. I want you to segregate the customers, maybe 1 lakh customers are there, segregate them into these three by looking at their behavior. Behavior nothing but, okay, so all the persons who are making a little bit low revenue to your platform maybe fall under the cluster 1 group 1. Medium kind of a revenue making into the cluster 2. The more revenue into the cluster. There is no output variable here. There is no output variable. We just seeing their purchase behavior. Purchase behavior. Okay, these customers are making a similar kind of a behavior. I will make them into group 1, group 2, group 3. And we had to manually look into it. What is there in the group 1, group 2, group 3? When you observe it, the customers are having the similar behavior like uh, they may be having the very low revenue making, high revenue or median revenue. That comes after you observe them, because it doesn't know it. We are not telling the model to, okay, you group them into the low revenue, high revenue or median revenue. We are just telling the model to group the customers who look alike in the behavior. So for that we don't need to have the result. The model will group them. As a person, human being has to be there. Look into that group. What pattern you can observe from that group? What is the similarity you can observe from that group? Probably you can observe the low revenue or high revenue, or maybe the here cluster one can be teenage people, cluster two can be middle aged people, cluster three can be old age people. Okay, it will just try to make it. That comes under the clustering problem. This is what we call it as a unsupervised learning. Unsupervised, there is no output. Okay, each and everything will have its own. What is the use of this one? What is the use of this groups and clusters? Can anybody guess?
To make the report, like if in any country they
Hmm.
want to calculate how many like the population of the country, so they can use this way to do that. Like
Yeah, maybe statistical reporting purpose you said. Apart from the reporting purpose, so of course every company will have their quarterly and annual reports for the sales and all, right? So using this, what action can be taken place? So one of the action can be, suppose you found the cluster, this group three customers are highly revenue making customer. You understood that, okay? And in that you can filter out who is not making a revenue, who's not coming to the platform from past 3 months or 4 months. Okay, you will understand, okay, these customers are really high revenue making customers in the past few years. But I observed them, they're not coming to my platform past few months. Something might have happened. What I can do, I can give these details to marketing people. Okay, these people might be churned. Maybe if you're a telecom company and you observe the three clusters and you observe these people are not coming to the platform, maybe have them migrated to another telecom network. So can you give this data to the marketing people? They will try to personalize coupons to them. Okay, so to bring back them to the platform. Eventually, your company has to make a revenue. So this is how you will get a marketing mails will be decided. Personalization will happen. Okay, this person behavior, what can be done? Okay, how we can make this customers into bringing into the platform and making him regular. So anything can be done.
Like
So yeah, tell me.
it's segregating the data.
Yeah,
It
segregating
means
the data. So in the business terminology, we can call it segregating the data. So we can target the high revenue making customer because there's no point of because 1 lakh customers or 10 million customers are there. And this cluster three, if it is a high revenue, it will be very few people. It will be not like in the millions, right? And targeting these people in this, you can look into it. Okay, who are not whose purchase behavior got changed in the recent days. Okay, why it has got changed? Can we target them? Can we send them a promotional emails or call them or do whatever to bring them back to the platform? So that can be done using this clustering or segregation. The names can be different, but the goal is same. So eventually, what did you understand? The models try to do the pattern matching. Pattern matching using some algorithm and training data, it will generate a model. So what is the important step in the training? For example, let's take a baby, just born baby was there. Okay, just born baby. So how do you train a baby? How do you train a baby? Suppose you want to teach a baby what is a cat and what is a dog. How do you train?
we can show that picture or
Excellent. You will show the picture. You
something.
maybe some small book will be there. You will have a 10 images of the cat, 10 images of the dogs for there. For example, okay, 10 images of the cat, 10 images of the dog. It's cat. You wanted to teach the baby what is a cat and what is a dog. Okay, so 1, 2, 3, 4, 5, 6. So you have multiple cats, maybe the white cat, the brown cat, or the black cat or kitten. Those are different breeds, and the cat on the table. Okay, dogs also German Shepherd or the pug. Okay, maybe let us say German Shepherd and the brown dog or black dog. So a lot of the dogs for information were there, and now all the dogs and cats were done in this 10. Okay, now you bring the 11th image and ask the baby whether it is a cat or dog. If the baby is able to identify it correctly, whether it is cat or dog, we can understand, okay, the model has trained perfectly. Okay, maybe you can not only one, maybe you can show three, four, and suppose you are showing the 10 images to the baby again. Okay, nothing about testing data here. This and all training. The testing, you are having a 10 images, and the baby is able to identify 8 out of the 10 correctly. Then you can say the 80% of the accuracy of the model. Correct, 80% of the accuracy we achieved. If the baby is able to identify 9 out of 10 correctly, we can call it as 90% of the accuracy. Maybe 10 out of 10, maybe we can say 100% of accuracy. So, but you brought the some new animal, like suppose you brought the pug. Maybe let us assume the pug is not there in the training data. So pug looks very small. It almost maybe the baby got confused and misclassified the pug as a cat. Okay, that means the baby did a mistake. The model did a mistake. So why it did a mistake? That is what we have to do. First of all, how The training of this data to a baby, what is happening inside the baby's brain? Baby will have neural networks, neurons will be there, neurons will fire whenever you look into some particular image. Baby will observe the features. What features? The eyes, ears. Okay, the cat eyes will be looking like brownish. The dog eyes are black, and the cat ears are like pointy, and the dog ears are like almost look. Dog ears also look like pointy, but the cat will have four legs. Dog also have four legs. Cat is having a tail. Dog also having a tail. Cat is having a mustache. Dog is not having it. Nose is of particular shape. This of particular shape. The dog looks big. Cat looks small. These are all features. When I mention the features, in the table data, it is very easy to understand the features. Nothing but column names. In the image data, the features are nothing but this kind of a perception fields in the images. And the baby can do the mistake when it is wrongly assume the features, or the feature extraction is wrong. Then baby can do the mistakes. Feature extraction itself is wrong. Maybe this data is not sufficient also. Maybe you are not covering the dog on sleeping on the tree. Maybe you are not covering the dog. Maybe some portion of the, maybe the cat, half of the cat is invisible behind the curtain. Only very little portion was there in the training data. Okay, there can be a lot of things can be happening whenever you are curating a data set. This is nothing but data set. Training data set, you have to prepare. You have to prepare that book, whatever you're training on. The cat images and dog images, and segregating is a cat and dog human job. Humans has to label it, right? Then you can use it for training. This is where it comes. The machine learning pipeline. Let me show you that. Yes. The data preparation step, where you have the label data or unlabeled data, whatever images or tables or text, the data preparation has to be done. This is the maximum time taking in entire AI role. If you are trying to build a model from the scratch, think about a chart GPT or Gemini, Grok, how much data they might have trained on. Almost entire internet of data, petabytes of data. How much data preparation step they need, how many years they have to spend, how many workforce they needed to data prepare, right? Scrape the data and do the stuff. And once the data is done, feature extraction. In case of a table data, it's a columns. In case of a images, it's a pixels. In case of a text, it's a words. What kind of data can be present? You might be I already told you. Most of the times you see the tabular data, or I can say call it as a structured data, tabular or JSON data. JSON, dictionary data. And image data you will see, and then text data. Text is nothing but the human language we speak, natural language, English, Telugu, Kannada, Hindi, German, Chinese. These and all text, which doesn't have any format. Tabular and JSON will have a format. Tabular. The images will have pixels. You will see these three category of data most of the times. Even the audio was there. So audio also eventually it will be converted into the text, right? So audio will be transcribed into the text. It comes under the text itself. If you are using the text field, we call it as the NLP problem. Natural language processing, we call them a natural NLP engineers. If you're working on the image data, we call you as a computer vision developers. Computer vision. If you are working on the this particular only the table data, okay, we call them as the data scientists. Right? And machine learning. Now the roles little bit merged. Now the roles are little bit shifting to almost everybody has to know everything. So that is what is happening. Okay, so earlier, so people when we use it to have the tabular data and this image data, it is fine. This text, or which we call it NLP, is a little bit difficult to deal with because it is unstructured, because it is not having any models to train, what would you train? What is your output goal in the text? So yeah. So whenever you ask a chat GPT or Gemini any question, what is happening behind that? It is trying to predict the next token or next word. Okay, depending on your question, it is trying to answer by predicting the next word it can go as an answer. That's why you can see the answer is generated word by word. Eventually, it's a prediction problem. Probabilities will be there, everything will be there. So this comes in ChatGPT, Gemini, Grok, everything falls under this NLP sector, natural language processing. So this is where generative AI has evolved. So in the conventional machine learning problem, so where you have the inputs and outputs and structured formats and all, we are not generating anything new. We are not generating the text. We are choosing from the given answers. So, but in the generative AI field, the model started generating something new, either in image or text. Coming back to the machine learning pipeline, so general data preparation, feature extraction, model training, testing the model. Once you are obviously good about the testing and accuracy is good enough, the model will be generated that will go for the predictions. That will go for prediction. If there is a mistake happen, like in the case of the cat or dog, baby can do the mistake, go back and observe if any features are missing. Okay, you add those features and do the training and testing again and make a model and prediction again, uh, make it productionization. Again, it did the mistakes. Maybe the problem is there not in the feature extraction. Maybe data itself is wrong. Go there and look into the data and add more data, remove the data, faulty data, do all the data cleaning stuff. Go for a feature extraction again, model training and testing the model, model productionization. This is like an entire cycle. It will be never ending cycle. Got it? And what you have to know as a technology, generally you might be seeing business analyst and data analyst kind of a roles. So business analyst is nothing but primarily they deal with Excels and problem solving communications. They don't need to have the much technical knowledge. But data analyst should have the knowledge about the data visualizations, Tableau, Power BI, SQL, Excel, little bit of statistics. This knowledge they should have it. Data engineers, this first of all we need to have a data, right? Without data, nothing can be done. AI is not no useful at all without having a data. Who will bring the data to the platform? Data engineers will bring the data to the platform. Like they will take the suppose click data. You are working for e-commerce. Okay, so entire clicks data should be coming or purchase data. Everything has to be stored into big data platforms because data is very huge. That kind of a huge data, how can it handle normal systems? You need to have a Hadoop, Spark, and uh, the big pipelines like where data can be orchestrated and kept it in a single place. Okay, so these people are built for ETL tools. So ETL tools like extracting, transforming, and the data and keeping into the data modeling pipelines. So this tools is different for data engineers, data scientists. These roles will be coming into statistics. You should know good statistics knowledge and machine learning knowledge also. Data visualization you should know, and the model building. So these and all mathematics is required to understand statistics. The machine learning engineer are slowly this was converted into generative AI engineer right now. So people has to have the more knowledge into the neural network frameworks like PyTorch, TensorFlow, and software engineering like distributed. One of you already mentioned you are a back-end engineer, right? You might be using the distributed computing, right? Deploying and monitoring the machine learning models or scaling. Those things has to be taken care by ML engineer. Okay, so machine learning technically, to be honest, it's a little bit hard, but compare it with generative AI. Okay, so let us see that. So what happened? How this generative AI has evolved? What happened? How this generative AI has been evolved? In the 2017, Google has published a paper. Do you know what is that paper? The paper is called Attention is All You Need. This paper changed the everything the world looking into. This paper has revolutioned nearly, it made it $1 trillion economy right now. This is that paper. What happened in this paper? This published by Google, you can see the Google authors here. This published in 2017. This is a revision, don't confuse it, it's a 2017 paper. So this is the architecture they published. The architecture is called transformer. This is a, you may not understand right now. It's an encoder decoder architecture. Primarily, it's based on the neural networks. Okay, so this architecture, almost whoever you name, the ChatGPT, Gemini, Grok, DeepSeek, Quen, you name any single LLM model. What is an LLM? Large language models, right? Why do we call it the large LLM? I will tell you. So everything uses same architecture. Maybe they will tweak it, but this is the foundation for it. So we'll discuss about this one also in the coming classes. So, but here, first of all, generative AI, it knows everything, right? ChatGPT or Gemini, whatever you're using right now, it knows everything. How it does know everything? Because it was trained on almost every single data, whatever you come across. For that, what you need to have a data preparation. You need to curate the data, keep it in a place, and you have to train. Train with, maybe I told you transformers is one of the architecture. Algorithm, you can think of like algorithms I told you, right? Algorithms can be transformer is the algorithm. You're training with it, you got the model as output. So how long will it take to train? Anybody is having any idea? This data is very huge. You need a algorithm you got. Next you need to have a machine to train. What machine you can train? You train in your computer, my computer. What is your computer? Can you tell me, anybody, all of you using it? Which computer are you using? Laptop or whatever. Windows, Mac, i7-99, CPU, right? That i7-99 is a CPU processor, maybe AMD processor. Some RAM will be there, 32 GB or 16 GB. Some SSD will be there, 1 TB or 2 TB. Do you think our computers will handle such kind of a thing? No, not at all. That is such a huge data. You need this algorithm to fit and train. So we need a supercomputer, which we call it as a GPU computer, graphical processing unit. Are you the gamers? Anybody play the games, especially the video games? You must be knowing the GPUs. So initially, general purpose GPUs are made for the graphical processing, but later, so it was used for the artificial intelligence. Without GPUs, nothing can be done. So who is the GPU provider? One of the GPU provider, NVIDIA, right? NVIDIA is the greatest GPU providers. So they have built a phenomenal GPUs, A100, H100 machines. These are all GPU machine names. Latest one B200, B100, H200 also there. These are all latest models. Currently, even if you are gamers, you will have a laptops with the GPUs. The GPU will be RTX 3080, 3070 or 5080, 5 series or 4 series. A lot of series for there. Anybody plays the games? No idea? No idea about RTX GPUs? PlayStation? No PlayStation gamers? Alright, so yes. So currently my system is having RTX 3080 8GB VRAM. So but then that is also not sufficient to train such a huge model. And not even single model. So single machine is sufficient. You may need 1000 machines probably. Maybe 2000 machines are required to train a single LLM. And how many days? Maybe months of training. You need electricity. These are all will be there. And of course, these are very expensive. This mission will cost more than a 1 crore in Indian currency, 2 crores, 3 crores, depending on that. That's the reason there is a shortage of GPUs and people has to wait for a lot of time. Most of their, you may see the lot of layoffs even recently. The Oracle has laid off the people because they wanted to buy these GPUs. They're converting everything, their funding into the AI data centers because these machines are much, much expensive. For that reason, they had to fire the people. Right. So, and it comes with a lot of cost. Can you build an LLM? You need a data set, you need a machine, you need a money. Then you can do the stuff. That's the reason generative AI is very, very expensive field, and especially to run, operation cost is pretty much high. Even for the cloud or whatever the model you use, the way they host it, they have to host in one of these machines. Not one machine may not be sufficient. In the scaling perspective, you need a thousands of machines, models deployed for it available to everybody, right? Yeah. And as I said, natural language processing is important for the generative AI. So coming back to this paper, so yeah, so let me ask you a question. So everybody knows the chat GPT, right? What is GPT? What is the GPT stands for? GPT stands for Generative Pre-trained Transformer. Generative Pre-trained Transformer. This is a transformer text, as I told you. So pre-trained nothing but already pre-trained by the OpenAI people based on all this data. So that's why pre-trained transformer model. So how many models are there in the ChatGPT? So can you just first of all, so to train such kind of a huge models, we have to train with a large language, and we call it as LLMs, which we call the large language models. All the things are LLMs, right? Can you name few LLMs you know in the market or whatever you have used so far? Which generative AI LLMs are you using it right now?
DeepSeek is one of them.
Yeah, DeepSeek is one of them, right? DeepSeek is one LLM, and as a charge
Like
GPT models for
GPT-4, GPT-5,
yeah, right.
these are.
GPT 4.0 nearly 10 to 12 are there. GPT 3.5, 4.1, 4.0 mini, 4.1 mini, 5.3. All the GPT series, I will call it as GPT X. Okay, all the models can.
Opus is there, Cloud is there.
That is part of the cloud, right? Cloud, Sonnet, Cloud Opus. Yeah, right. Yeah, Cloud Opus or Sonnet, Hike. These are all cloud models.
Gemini also considered.
Yeah, Gemini. Yeah, right. Gemini models like what are the Gemini models? Gemini Pro 3.1 Pro Flash models and Pro models was there, right? Right. And
Perplexity.
Perplexity itself is not a model, but it's a collection. They will provide an option to choose these models. Okay,
Mhm.
so that itself not an LLM, but as an orchestrator of these LLMs. Maybe Perplexity will have, if you open the Perplexity in the drop down, you can select the model, right? So yeah, they will have their own proprietary models also. They call it a sonar, but Perplexity itself is not a model. And what else?
Like we use WhatsApp in that Meta AI is always written.
Excellent. Yeah. What is that? Can you name that?
Meta AI.
Just read about it. Meta AI. What is there in the bottom? Powered with?
Oh, okay. Search Meta AI or search is written, but
Okay, it's not written.
yeah,
Wait, let me see. I
okay,
think
now
they
it is.
removed it. I think yeah, they removed the name. Okay.
Earlier it
It
used
used it. Yeah, powered with Llama. Generally, Llama 4. It will be there.
oh, okay.
Llama models are from the Meta. DeepSeek is from China. This GPT is from DeepSeek is from the China that models, right? So that company I forgot the name, but this is like OpenAI. This is a Claude is nothing but from the Anthropic. Gemini is from the Google. Llama is from the Meta. And what else models? So you probably maybe Grok is there na? This may be no X.com, Twitter, and are you using the Grok? And so can you name how many do you think are there? Just for the name, roughly, can you guess some number? How many generative AI models could be there? Maybe AI models. What do you think? When I can name few, Quen is there. Quen, Phi, Mistral. You might not be hear these names, but just guess a random number. How many? 20, 30, 40, 100, 200? No idea. What is this number? What is this? 28 lakhs? 28 lakhs open source models are there. In that, like ChatGPT text generation itself, we have 3,52,598 models available in the open source world. So you cannot download these models, right? The Claude, GPT, Gemini, Grok, this you can't download. Llama you can do. Llama is open source. These are all proprietary models. Proprietary models, they provide an API. You can interact with them, but you can't download the models to run it in your own server. Proprietary. These are all proprietary. Quen is open source. Phi also open source. Mistral is open source. Like that, open source itself, lakhs of models are available. Okay. Even the image generations, image to text. You can see this many image to image, text to image. This is Hugging Face website. This will go through during the course. Yeah. Apart from this, so these and all over there. So when to use what? Open source are required when you want a security because you are sending your data to ChatGPT, OpenAI, and all, right? So you don't want to send it. You have to have your open source model deployed in your own computer, maybe in your own server. Then you have to use the open source. Most of the companies who don't want to expose their data, they will use open source. So let me show you the. Let me walk you through the syllabus of this agentic AI and generative AI.
I have a question here. Like, if a
Yeah.
company means they cannot use those
Hmm.
proprietary models to their system,
Hmm. It's up to them. This
like
company, which company you're talking?
means any company. Like, for example, if X company wants to set up a internal, LLM for their company or their internal purposes, so
Hmm.
they cannot opt any proprietary models for them.
They can. That depends on the company's goals and if they want a confidence. Suppose if you're working for a banking domain and you wanted to use the
Mm-hmm.
customer information leaking to the people, you don't want to do that. Suppose you are
Correct.
giving
Mm-hmm.
this customer data to the OpenAI. Let us say that, and they will
Mm-hmm.
retain this data for 30 days. Okay, irrespective of whatever you do, they will have this data in their servers, maybe US or wherever the
Okay.
servers are located.
Mm-hmm.
What if some hacker comes to that platform, hack everything? All
Okay.
the confidential information of the banking domain, maybe healthcare domain, is leaked out, right? How
Mm-hmm.
much riskier it is to use. Instead of that, take an open source model, deploy it in your own server, and the data is internal. It is not leaking out, right? You can have a control over it. In that
Right.
case, people use the open source models, and those are more powerful nowadays. Like open source models are much powerful. Depending on the large language comes from the number of billion parameters. The parameters are
Mm-hmm.
nothing but a network in the neural network architecture, right? So each connection we call it as a parameter that I can't explain right now, but the number of parameters will decide the how big is your model is. Okay, so
Okay.
yeah.
Sure. Thank you.
So coming to this one, so you have to understand a few things. So as part of our first thing, we will introduce the generative AI, what is it and all, and then we'll go through the NLP, so natural language processing, like regular expressions and tokenization, stemming, lemmatization. These are all the techniques to understand the text, like English or Telugu or whatever the language. We try to understand the text. And how do you convert this text into the numbers? We call it text representation, and we call it word embeddings. So those has to be there. We call it even word embeddings or vectors. We call the text we had to convert into the numbers. And the model generative AI, how the transformers and LLMs are being used. And once this is done, we'll go into foundational models like pre-trained transformers, pre-trained versus fine-tuning. Like you wanted to use the pre-trained model like ChatGPT, LLM, or open source world, or you wanted to bring your own model because you see the all these LLMs, whatever you are using, they don't know your data, right? Maybe you're having your financial data, you're having healthcare that doesn't know, and
Mhm.
you some of the limitations will be there. These models probably you may have to train with your own data. That is we call it as a your training from the scratch is very expensive. Okay, so we use a technique called fine tuning. This is also part of the training. So I will tell you a very good example. Uh, so one of the example is suppose you had to study the 10th class. What you had to do? You had to go from the first, second, third, fourth, fifth, sixth, seventh, 10 years. You have to wait, study everything, and pass the 10th class. You will have all the knowledge. Or the alternative shortcut is you look for a person who already studied the 9th class. Okay, maybe 8th class. You take their brain and keep the brain transplantation. You have the entire knowledge of that 9th class person. You only have to spend only 1 year for the 10th class, right? So that is what I mean by fine tuning. This is it. I just explained in the very vague terms, but in the real way, there is a neural networks. You have to add more layers without changing the existing layers. That is what it will happen in the fine tuning. Okay, and apart from that, and even we have the text generation, image generation, audio generation, multimodals, and we'll look into the closed source first, proprietary models like we you might be using the UI, right? That is not how the applications will be built. Applications to build, you have to know the Python. Using the Python itself, we are going to build the OpenAI, Gemini, Anthropic, these kind of models will interact with it using API calls. And we even experiment with open source models. We try to deploy it. Maybe large models we can't deploy, small models we can deploy it into our local systems and run it in our local itself. So the data will be secured. And we even deal with the Quen, Olama. Olama is one of the framework where we can deploy the stuff. And Grok also not GROK, GROQ. This is another cloud provider where we can run open source models. And prompt engineering, this is really important how you will be dealing with the things. And it would take a couple of days to explain. The prompt engineering is really important for the models to run, right? And then we will deal with the RAG. RAG is one of the vector data. You might be hearing the databases like RDBMS, like Oracle, MySQL. Those databases are not useful when it comes to generative AI. We need to have the vector databases where the numbers will be there and all. So these are new database systems rather than conventional things. So this will be storing the matrices, nothing but we call them as vectors, and some of the mathematics will be included. Some of the vector database to name: ChromaDB, Phase, Vector, Qtrant, Milvus, VV at Pinecone. These and all comes under the vector databases. I introduced to that. Then frameworks like LangChain, Hugging Face. To build the agentic or generative applications, you need some framework. The LangChain and Hugging Face. These and all very better way. Hugging Face is like model repository. LangChain is like where we can interact with all these models and build the applications, even deployment and observability and all we will see. And the RAG system, retrieval augmented generation. This is one of the primary use case anybody has to build. Every company, without this RAG, they don't have any applications. RAG is the fundamental. Even we'll deal with the Streamlit, Gradio, and REST APIs and all. And Agentic AI, where we deal with how to build an agent using the Crew AI framework and LangGraph frameworks. Yeah. So this is our entire course, which would take around 2.5 to 3 months of time. Yeah. So any question? I know most of you guys are very new. Even I try to explain these things I may not be because the syllabus is a little bit huge comparative to the conventional. So since we are starting from the scratch, I want you to have the basics of the fundamentals of the Python. Then you can good to go ahead with this thing, right? Any questions? Any questions here regarding the syllabus or? any other related stuff.
What's the timing? Sorry, go ahead.
Timing is same. Whatever the demo you're attending right now, right? It's same time.
Okay. And it is on every day, like
It's 5 days a week, like mostly Monday to Friday in your time zone.
okay.
Yeah, basically, yeah, that is the one. So I basically from the India, not from US. So my timing is different. I can say like 8 a.m. to 9 a.m. in India time.
And we'll be able to get some hands-on experience, like,
Isn't all not the isn't all Python labs, not just the theory.
okay.
These and all Python labs projects. These and all whenever I mention right, everything is a Python code application building, not a theory. Everything is a
So these are
hands-on.
hands-on
Yeah,
topics, right?
everything is a hands-on. Yeah, definitely. These are not the theory will be there. Very few things. When I mentioned regular expression, and all these and all. So theory and practical we will do together. Yeah. So the only thing is you need to have the Python fundamental knowledge that is a prerequisite for this course. Yeah, nothing else is required. That is fine.
So Ganesh, just a question, like since I'm a Java developer and never get a chance to
Mm.
work on Python,
Mm.
so shall I learn first Python or we can do it together?
You can fundamentals of the Python. What I mean is, if you are a Java developer, Python is a very
Mhm.
easy for you to do it. It's nothing. If the Python Java is the 10th level, the Python will be at 2 or 3. Okay, so just how to create a variable, how to use a for
Mhm.
loop, how to create a the what do you call this functions. That is sufficient. These are
Okay.
fundamentals. That is what I mean by fundamentals of the Python,
Mhm.
right?
Okay.
So yeah, not like data structures and DSA and all. They're not what I mean. So Python is a very syntactical programming language and very easy. It is hardly will take a couple of hours, not more than that.
Uh, Here's one question. Okay, apart from this, means just to understand.
Mm.
So for example, in Java and all, we have been developing the RESTful APIs, right?
Mm.
Using Spring Boot and other frameworks. So is this training we can use it for using the Python as well? We can develop those part.
That's what here REST APIs I mentioned. When you see, we will
Okay.
use the Fast API or Flask framework. You use Spring Boot in the Java. Here we use Fast API
Uh-huh.
and Flask to build the REST APIs.
Okay.
Yeah, it's very easy by comparing with. I know I also came from Java background. Okay, so
Mhm.
comparatively, you feel much more easier in terms of the syntax and the Python programming because Java comes with a lot of JVMs will be there. You have to compile it and do the stuff, and you need to know the
Mhm.
lot of frameworks. But here, it's nothing is required because here the libraries are completely different. We deal with the libraries. Most of the libraries are new to you. Right,
Okay.
transformers, PyTorch, Spacey, NLTK. These and all scikit-learn. These and all new to the people who are coming into the AI. Now, it's not about coding. Don't worry about the coding. Worry about how do you understand. Right, that is the
Mhm.
main thing. So coding is nothing. It's very easy.
Sure.
And
Thank you.
yeah,
Yeah.
yeah, cool. Yeah, anyway, so you guys can give a feedback or you can interact with whoever sent you the class link, right? You can just tell them okay,
Mhm.
whether you're interested or not, so that they will approach me. So generally, there will be people who are dealing with this theme, and they will hire me to do the trainings and all. Okay. So whoever interested, please approach to them immediately so that we will have a count. So we will see if a couple of maybe sessions will happen demo. Yeah, I think few of the people are missing today. Uh, for them, I can forward this recording. Yeah, whoever having any questions or doubts or interest, you can just message to the person whoever sent you this link, this Zoom link, right? Yeah,
Okay.
yeah. Thank you all. Have a nice day. Bye.
Yeah, thank you.
Thank you,
Thanks.
Ganesh. Thanks a lot.
Yeah.